In the collective memory of maritime disasters, the RMS Titanic stands as the ultimate symbol of hubris and tragic loss. Yet, hidden in the freezing darkness of the Baltic Sea, lies a wreck that eclipses that famous tragedy by a staggering factor of 6. On January 30th, 1945, a single vessel took an estimated 9,400 lives with her to the seabed, the greatest single-ship loss of life in maritime history. The Wilhelm Gustloff was not a warship built to absorb torpedo impacts. She was a masterpiece of civilian engineering, a flagship of the Kraft durch Freude, Strength Through Joy program, designed for sundecks, open promenades, and dining halls, not the brutal mathematics of total war. When we analyze the logistics of her final voyage, we do not find a mere accident, but a collision of desperate strategy, failing infrastructure, and fatal design limitations. This is the story of the Wilhelm Gustloff and the strategic flaw that sealed its fate. We will dissect how it was designed and why it failed. To understand why a civilian liner was pushed into the crosshairs of naval warfare, we must first analyze the strategic collapse of the Eastern Front in early 1945. By January, the Soviet Red Army had cut off East Prussia, trapping millions of German civilians and military personnel in a shrinking pocket of territory. The German High Command initiated Operation Hannibal, a naval evacuation mandate that would eventually dwarf the rescue at Dunkirk. The objective was simple, but structurally overwhelming: evacuate everything that could float. At the port of Gotenhofen, the Wilhelm Gustloff had spent 4 years as a static barracks ship for the 2nd Submarine Training Division. From an engineering standpoint, she was effectively a floating building, her engines cold and her hull neglected. Reactivating her for a high-speed open ocean transit in winter conditions was already a calculated risk. But the logistical demands of Operation Hannibal ignored safety margins. When we analyze the embarkation data, the numbers defy standard maritime safety protocols. The Gustloff was designed with a maximum capacity of approximately 1,900 passengers and crew. On January 30th, under the chaotic pressure of the advancing front, the gangways were overwhelmed. While the official manifest listed 6,050 people, modern forensic estimates suggest the true number was closer to 10,582. This extreme overcrowding created a critical operational hazard. Every corridor, stairwell, and promenade deck spaces designed for leisurely circulation was packed shoulder to shoulder with refugees. The ship's center of gravity shifted, and her internal traffic flow, crucial for damage control or evacuation, was effectively paralyzed. Furthermore, her status as a non-combatant vessel was compromised. Because she carried naval personnel, flak cannons, and did not display the Red Cross markings of a hospital ship, she was, by the strict definitions of naval engagement, a legitimate military target. As she cast off from the pier, escorted by only a single torpedo boat, the Löwe, the Gustloff was not sailing as the pride of the merchant marine. She was a frantic, overloaded vessel, sailing into a Baltic Sea that was teeming with Soviet submarines, carrying a population equivalent to a small town inside a hull that was never meant to protect them. To understand the mechanics of the disaster, we must look beneath the skin of the Wilhelm Gustloff. When we bring up the general arrangement plans from 1937, we are looking at a vessel that was revolutionary for its time, but structurally ill-suited for the mission of 1945. The Gustloff was the flagship of the Nazi Kraft durch Freude, Strength Through Joy program. She was the world's first classless cruise ship. In traditional naval architecture of the era, ships were vertically segregated by class, often creating rigid barriers between decks. The Gustloff, designed to project an image of social equality, featured an open architecture design. As we rotate the 3D model to inspect the accommodation decks, we see cabins of identical size and vast open communal spaces designed to facilitate the free flow of 1,465 passengers. While this was a triumph of social engineering, it was a liability for damage control. Unlike a warship, which is built like a honeycomb-dense lattice of small, redundant, watertight cells designed to contain flooding, the Gustloff was built for volume and visibility. Her interior was defined by long corridors and wide stairwells. In a combat scenario, these open spaces act as highways for water. If the hull is breached, the water doesn't just fill a compartment. It surges through these leisure spaces, gaining free surface effect and destabilizing the ship rapidly. Our analysis of the watertight bulkheads reveals another critical limitation. The ship was equipped with 13 transverse watertight bulkheads. In theory, she could stay afloat with any 2 adjacent compartments flooded. However, these bulkheads only extended vertically up to D deck. Above that line, the ship was essentially open. If the ship listed enough to dip D deck below the waterline, water would simply spill over the tops of the bulkheads like an overflowing ice cube tray, cascading progressively from one section to the next. Furthermore, we must examine the promenade deck, highlighted here in the cross-section. A signature feature of the Gustloff was her enclosed glass promenades, designed to protect vacationers from the North Atlantic wind while offering panoramic views. The heavy, reinforced glass windows were permanently fixed. In a capsizing event, these enclosed decks would become death traps, preventing escape and quickly filling with water once submerged, dragging the center of gravity drastically to the side. Complicating the structural design was the condition of the ship in 1945. For 4 years, she had sat at anchor as a barracks. When we zoom into the lower decks, particularly the crew quarters and the drained swimming pool area on E deck, we find that temporary bunk beds had been welded or bolted into every available square meter to maximize accommodation. Crucially, the watertight doors, massive hydraulic barriers designed to seal off the bulkheads, faced a mechanical obstruction. Reports indicate that due to the extreme overcrowding, electrical cables, luggage, and temporary bedding were run through the door frames to support the refugees packed into the corridors. When the alarm sounded, it is highly probable that many of these doors could not fully seal. The Gustloff was not just a civilian ship in a war zone. She was a compromised hull, her internal safety systems effectively sabotaged by the sheer density of her human cargo. She was sailing with her arteries unclogged, ready to bleed out at the first strike. The timeline of the disaster crystallizes at 1800 hours on January 30th. The Wilhelm Gustloff is cutting through a force 7 gale, the temperature plummeting to minus 18 degrees Celsius. Visibility is near zero due to driving snow. Here, a critical tactical decision is made. Fearing a collision with a convoy of German minesweepers reported in the area, Captain Peterson orders the ship's navigation lights activated. In the darkness of the Baltic, this act transforms the Gustloff from a ghost into a beacon. Lurking on the surface, patrolling the shipping lanes off the Pomeranian coast, is the Soviet submarine S-13, commanded by Captain Alexander Matanesko. Our reconstruction of the S-13's log shows Matanesko spotting the illuminated liner almost immediately. But rather than firing from the open sea, Matanesko executes a daring maneuver. He steers the submarine between the Gustloff and the coastline, positioning S-13 on the landward side of the target. This places the submarine in the darker, shallow waters, while the Gustloff is silhouetted against the open sea. At 21:08, Matanesko orders 4 torpedoes flooded. The tubes are painted with dedications. For the motherland, for the Soviet people, for Leningrad, and for Stalin. The 4th torpedo jams in the tube, a mechanical failure that nearly destroys the submarine. But the first 3 run hot and true. The radar and sonar reconstruction of the attack reveals a devastating spread. The first torpedo strikes the bow near the anchor chain. The explosion blows out the forepeak, instantly flooding the crew quarters where off-duty officers were sleeping. The watertight doors here, likely sealed, hold momentarily, but the shock wave ripples through the ship's steel frame. Seconds later, the second torpedo strikes. This is the catastrophic blow. It impacts amidships, slightly forward, punching directly into E-deck. This area housed the drained swimming pool, a vast, tiled cavern that had been converted into quarters for the Women's Naval Auxiliary. The blast does not just breach the hull, it shatters the mosaic tiles and the glass roof above, turning the architectural features of the luxury liner into deadly shrapnel. Because of the large open volume of the pool area, the water intake is massive and instantaneous, creating a violent free surface effect that immediately drags the ship's stability curve into the red. The third torpedo strikes the engine room. This is the coup de grace. The explosion tears through the machinery spaces, instantly killing the power. The Gustloff goes dark. The emergency lights flicker on, casting a dim red glow, but the pumps are dead. The ship is now drifting, taking on thousands of tons of water with no propulsion and no power to mitigate the list. We can now visualize the hydrodynamics of the sinking. The Gustloff immediately lists to port. Remember the bulkheads we analyzed in Act 3? They only extended to D-deck. As the bow drops and the port list increases, the waterline rises above the D-deck threshold. The water begins to cascade over the tops of the watertight compartments. The ship's internal subdivision is rendered useless. On the upper decks, the strength through joy design features turn fatal. The wide, glass-enclosed promenades, now tilting at a steep angle, become slick slides of ice and glass. The davits, frozen solid by the sea spray, jam. The thousands of passengers trapped in the lower corridors, the civilian hull, surge upward, but the narrow stairwells create lethal bottlenecks. The center of gravity shifts further to port as thousands of people scramble to the high side of the ship. Within 50 minutes, the list becomes critical. The starboard side rises high into the air. At approximately 2200, just 1 hour after impact, the Wilhelm Gustloff loses her fight with buoyancy. She rolls completely onto her port side. The funnels crash into the sea, crushing the lifeboats that manage to launch. With a final groaning shudder of tortured steel, the flagship slides bow first into the 44-meter deep abyss, taking the majority of her 10,000 passengers with her. When we step back to conduct the final forensic audit of the Wilhelm Gustloff disaster, we find a tragedy layered with multiple points of failure. While the Soviet torpedoes were the executioners, the death warrant was signed by a convergence of tactical errors and fundamental engineering mismatches. Tactically, the decision to activate the navigation lights was the immediate catalyst. In the unforgiving calculus of submarine warfare, emitting light in a combat zone is a fatal error. Captain Peterson's fear of a collision a risk, managed by standard convoy discipline, blinded him to the far greater threat of the S-13. That single switch transformed the ship from a hidden target into a firing solution. However, our analysis suggests the catastrophic loss of life was preordained by the logistics of Operation Hannibal. The Gustloff was operating at over 500% of her designed capacity. The lifeboat capacity, even under optimal conditions, could only save a fraction of the souls on board. When we factor in the frozen davits and the list, the survival equipment became statistically irrelevant. From an engineering perspective, the Gustloff confirms a brutal axiom of naval architecture. Comfort and survivability are often inversely proportional. The very features that made her a triumph of the Kraft durch Freude program, the open atriums, The glass promenades, the low bulkhead thresholds, stripped her of the resilience needed to survive a kinetic strike. She was a soft-skinned, open-volume vessel thrown into a theater of total war. Her compartmentalization was designed to contain fire or minor leaks, not the violent energy of high-explosive warheads. Once the hull was breached, her internal geometry worked against her, accelerating the progressive flooding that dragged her under. The Gustloff serves as a grim case study in the misuse of maritime assets. She was a machine built for leisure, forced to perform a military miracle, with no margin for error left in her design. In the cold silence of the Baltic seabed, the wreck of the Wilhelm Gustloff remains a designated war grave. It stands as a monolithic reminder that in the total mobilization of war, the distinction between civilian engineering and military targets dissolves. It is a monument to a ship designed to bring joy, which ultimately delivered a tragedy of unsurpassed magnitude.